Question number 18. Calculate the delta G's for the reactions below using the provided data. Assume 298 Kelvin is the standard temperature for your calculations. So we've done these calculations a lot already in the previous worksheet. So these, to calculate the delta G, we have this equation. And to calculate delta H, we do the heats of formation of the products minus the heats of formation of the reactants. Okay, and then to calculate the delta S, we do the delta S, the sum of the S's for the products minus that for the reactants. Exactly the same. Okay, so for this first one, let's look at the table. So to calculate delta H, we have minus 127.1. Okay, and then we have minus 1 times 105.6. The minus 1 for the negative coefficient because this is now a reactant. And then we have minus 1 times minus 167.2. So this is going to equal minus 65.5 kilojoules. Okay, and so delta S is equal to 96.2 minus 1 times 72.68 minus 1 times 56.5, and this will equal minus 33.08 joules. Okay, so this is joules, this is kilojoules. Notice the make sure in our next calculations that we have to convert these units. In the delta G, we're going to calculate using those values, delta H minus T delta S. So plug them back in. We're going to have minus 65. So what is this type of reaction? This is an exothermic reaction. And then this is in kilojoules. And then we have minus 298 Kelvin times minus 33.08 times 10 to the negative 3. Because we got to convert to kilojoules also. This is kilojoules or Kelvin. Okay, and so this equals minus 55.64 kilojoules. Okay, and so therefore this is going to be a spontaneous reaction at standard temperature because it's negative. Okay, now let's do part B. Okay, so again we're going to calculate the delta H reaction. So here we have CH3OH, so we have minus 238.7, and then we have minus 1 times 0. Graphite is 0 because this is standard state of carbon. Then we have the standard state of oxygen is 0. Standard state of hydrogen is also 0. Right, the empty blanks mean 0, which makes sense. Okay, and so therefore the heat of reaction is minus 238.7 kilojoules. Okay, so this is what? An exothermic reaction. Delta H is negative. Okay, let's calculate delta S. Okay, so again, stage 3 OH, we have 126.8. Minus for graphite is going to be 1 times 5.70 minus 1, right? Negative coefficient. And then we have minus 1/2 times 205. And then we're going to have minus 2 times 130. This equals minus 242.64 joules per Kelvin. Okay, so now that we've calculated everything, we can now do the delta G calculation. So delta G equals delta H minus T delta S. So if we plug in those numbers, we get minus 238. .7 kilojoules minus 298 Kelvin times minus 242.64 joules per Kelvin. Okay, and so we want to convert this to kilojoules. So this would be also times 10 to the minus 3. So this equals to give us kilojoules. And so this gives us a number of minus 166.39 kilojoules. So again, this is a spontaneous reaction at 298 degrees, 298 Kelvin.